Hello everyone, I hope you all are fine. So let's discuss about this new video. This video is related to continuity part 3. This is the part of your chapter number 5 class 12th continuity and differentiability. Okay. So in this video we are going to focus on composition of functions. So let's discuss about the composition of function. Okay. Composition of function at elementary level we have already discussed in the chapter number 1. So here we are going to discuss the composition of function in relation to continuity. So for that I have taken one of the theorem. So first of all you start understanding this theorem. So what is the statement of the theorem? Let's read it. Let f and g be real functions. Real functions means real valued functions such that f of g is defined. If g is continuous at x equals to a and f is continuous at ga, show that f of g is continuous at x equals to a. This is what the statement. It means what do they want to say? They want to say that there are two functions. We are considering basically f and g. So what is happening? That g is the function. Just see. What is the statement? Just see this. They are saying that g is a function that is continuous. Okay. It means this is continuous. Then they are saying ki this is continuous at x equals to a. At x equals to a. And what about our next function, that is f? F is continuous at ga. Okay, f is continuous at ga. Then they are saying the composition of these two functions will also be continuous. This is what we want to prove. So let's see how are we going to prove. In theorem, every word is very important. So first of all they have said f of g is defined. F and g are real valued functions and f of g is defined. When we say that the composition of function is defined, f of g is defined, so what does it mean? It means that the range of function g is a subset of domain of function f. Okay. Again you re-listen it. What does it mean? That whenever we write the composition like f of g, it means the range of the letter function is the subset of the domain of the form of function. So this is what we have written here. On the basis of f of g is defined, this is what the statement that we have written. Range of g is a subset of domain of f. Okay, clear? Now what have they said? In the theorem, they have said that g is continuous at x equals to a. In the last video also, I have discussed with you when we say a function is continuous. So what is the meaning of that? That the limit value of that function is equivalent to the function value. Okay. So we can write on the basis of this statement, we can draw this conclusion that limit x tends to a, gx equals to ga. So on the basis of this, we got this, and on the basis of this, we got this. After that, just look at this diagram. This is primary, then GA, and this is FGA. Or you can say X and GX and F of GX. Okay. So this is G function and this is F function. So it means what is GX? GX is the domain of F. And what is X? X is the domain of G. So they have said that GX belongs to domain of F for every X belongs to domain of G. So that is obvious. Okay, from this diagram you can conclude this. So G is continuous at x equals to E. Now two things we have already sorted. Fog is defined, so we got this result, and G is continuous at x equals to A, so we got this result. Now what have they said next? They have said f is continuous at GA. When they are saying f is continuous at GA, so what does it mean? Actually just try to understand it first, then I will show you. Limit, it means now gx is tending to GA. This is what happening because your f is continuous at GA, and this is the diagram that we are following. Now what is the function? That is f of gx. f of gx. Okay, so in place of gx what are we going to write? Ga. So this will become f of ga. Okay, so with the help of this we are going to get this result. So remember this, in the next slide we are going to do further steps. Okay, so now you see, this is what I wrote earlier, this is written here. Now what is your aim? Actually you want to prove that limit x tending to a, okay, f o g x, what will happen? Why is it so? Because this was your first function g and then your function was f, and you want to prove that the composition is also continuous. This is what you want to show. So for proving that, so you know very well what will be the domain in this case. Obviously the domain will be a. So x is tending to a, domain will be x, and we are pointing, a is a point in the domain. So limit x tends to a f o g x, and f o g x can be written as f of gx, that we have already studied. And from this result f of gx is nothing but f of ga. So we can write f of ga here. So this will become f of ga. Okay, f of ga. So f of ga can be written as f o g of a. So this is what written in these lines. So what do we got? We got that the limit value is equivalent to the function value. Therefore we can say that composition is also continuous at x equals to a. Okay, so just do it theorem one more time in your copy, then you will understand it in a better way. Now let's see an example based on this theorem. What is that example? Show that the function hx modulus of sin x plus cos x is continuous at x equals to pi. This is your question. Okay, now how to do that? One method is very easy. First of all, obviously this is the question related to composition of function. So we are going to break it in the composition. How? Just look at the solution. We have considered first function as sin x plus cos x and second function as mod x. It means mod function we have separated from this function whatever was given inside. Okay. Now directly I can tell you that in 11th standard you have studied that all the polynomial function as well as sin and cos x, these functions are continuous at each and every point. Okay. So sin x and cos x both are continuous function, and in the last video I told you about the algebra of continuity. So in algebra of continuity you have studied if 1 and 2 both function are continuous at some point, then obviously their sum will also be continuous. So as sin x and cos x are continuous at pi, therefore their combination, their sum, sin x plus cos x will also be continuous. So fx is continuous obviously, and gx equals to mod x. Okay, so if this is also continuous, then obviously from the theorem we can conclude that the composition is continuous. So we want to prove that their combination, their composition, if we find their composition, it means if we consider gof of x is g of fx. Okay, it means wherever the g function is, you put, wherever there is x you put fx. So what this will become? Modulus of sin x first and then plus cos x and then modulus. Okay, so obviously actually gof of x is nothing but the function hx. So this is how we have broken this function into two other functions, fx as well as gx. First of all, you remember this. Now we want to prove that this hx is continuous. So if we want to prove that hx is continuous, from the help of the theorem, the last theorem that we did, we will prove that the fx as well as gx are continuous. If we will prove that fx and gx are continuous, obviously their composition will be continuous by the help of the theorem. So this is how we are going to do. This is the diagram that I have drawn just for your convenience. Okay. So first of all, let's see whether f is continuous or not. Already I told you with the help of one method that this is continuous. Now you see by a other. Continuous means we have to show that the limiting value is equivalent to the value of the function. So limit x tends to pi fx. Fx is sin x plus cos x. If you are going to put pi, then sin pi and cos pi. Sin pi means 90 plus 90, that will be cos 90, and cos 90 is 0, and this will be minus 1. So your result will be minus 1. Now if you are going to find out the value of the function at this point, any f pi will be again sin pi plus cos pi, and again this will be equivalent to minus 1. This line is written here. Okay, so function value is also minus 1 and limit value is also minus 1. So both the values are equal, then we can say that f is continuous at x equals to pi. Now we will check whether g is continuous or not. Okay, so let's see. For showing that g is continuous, what our aim is, we are going to show, just pay attention, we are going to show that limit gx, okay, gx tending to ga and f of ga. In the last video, in the last theorem, I discussed this with you. If we want to show for the second function, then we write in this way. So now according to the need of the question, we are going to change it. So we can write it like in this way, limit y tending to minus 1. Minus 1 is used for f of pi, and y is nothing but f of x. So f of x to f of pi, and this is gy. Gy is nothing but g of f of x. Okay, so in place of fx, what are we going to put? F pi. So f pi means g of f pi. So that is mod y. Okay, gy is nothing but mod y. And if you are going to put minus 1 in mod y, then definitely your answer will be 1. So g of f pi is equivalent to 1. You will get 1. And if you directly find out the value of the function at minus 1, g of minus 1, then also mod of minus 1 is nothing but 1. So it means the function value is equal to the limit value. So therefore we can say that g is also continuous at pi. So both the functions are continuous at pi, then their composition will also be continuous at x equals to pi. So this is how you are going to solve the question. Okay, so you can use the theorem, and this theorem has many applications. Many questions are based on this theorem. So you just try many other questions. As many questions you solve, your definitely concept will be strengthened. Okay, so hope you understood it. Just try it better. Just try to solve it at home. And if you have any problem, you may ask your query. Thank you so much.